So we're going to take a look at tree diagrams. Now, tree diagrams are really helpful in visualizing problems, so that's a major pro, but a major con is that these can get complicated very quickly. They can get, not complicated, but they can get expansive. So let's take a look at a pretty simple scenario. So a true-false quiz has 3 questions. Draw a tree diagram for the scenario. So usually we've got some sort of starting point here, and we're going to say, okay, question 1, and we can think about that. I'm just going to do Q1 up here. So question 1, right, we can either get to a place where our answer is true or our answer is false. So not too bad, right? And I'll just do start over here, started the exam. Then we can say, well, all right, if I answer the first question true, then again, I've got 2 options. I could answer the second question true or the second question false. So this is going to be sort of my column for Q2. And the same thing, the same options are possible. So if I answer the first question false, well, okay, I could answer the next one true, or I could do false and then false. Right? And then from each of those possibilities, we get to question 3, and we say, okay, well, still, then I have true or false, true or false, right? We can kind of go down the line like this and say, okay, these are all of my different possibilities. And this is why we say, like, okay, yeah, it's a nice visual and everything, but it definitely can end up taking up a lot of space. So if you have more questions, let's say we had 10 questions, and instead of true false, if these were multiple choice or something where you had A, B, C, D as your options, well, from the start you'd have 4 different things, A, B, C, D, and then from each of those you'd have to have 4 more. And if you have 10 questions, that means, right, you're writing this thing way out. So it's not great for more complicated scenarios, but it starts you down a path. So for example, if we get to this node right here, what that means is we had true, true, true. So this is basically getting to the place of a response of true, true, true. The next one is getting to a place of true, and then false. Right, one down here, I'll just choose one down here, would be false, and then true. So F, F, T. Right, so this kind of lists all of our different possible paths that we could go down. And, the way you could think about this is from the start, going down one of these paths to a node, and just kind of say, okay, as I go, that's going to be the order of my questions. So why is this useful? Well, we can ask a lot of questions about this. So one thing that we're going to ask here is, if a student selects answers at random, what's the probability they get all questions correct? Now, we don't need to know what the questions were or what the correct answers were. What we can look at is, well, how many possible paths could that student have gone, right? If they're selected at random, we just say, how many of these little nodes, or because it's a tree diagram, how many of these leaves, a lot of times we'll call them, how many of those are there? One of them is the correct path. We just don't know which one. So the probability that they're all correct is 1 out of however many possible paths they have to choose from. So the nice thing about this, we can just go down the line and count them. So 1, 2, 3, 4, 5, 6, 7, 8. So there's a 1 in 8 chance that the path that they took was the correct path, right? That the question responses were correct and in the correct order. And again, we don't really need to know, but we could say, well, let me just suppose that this one that we did before, false, false, true, maybe that was the correct path. If we want to think about those probabilities, we can say, okay, well, there was a 50% chance that we would have answered the first one false instead of true. And then from there was a 50% chance that we would have answered the next one false, kind of like flipping a coin. And then now that we have false, false, there's a 50% chance, or 1/2, that we would have answered the third question true. So this is 1/2 times 1/2 times 1/2 is another way to get there. And right, let's think about what false, false, true means. What this means is that we had false and false, and true. So if we're looking at this from a probability standpoint, and these are independent events, right? Question 1, we're going to assume has no bearing on our response to question 2, has no bearing on our response to question 3, then we would say, oh, the probability of these AND scenarios means I just multiply their individual probabilities. So we say, okay, cool. We're going to see more examples of that, of course, but this is kind of the idea and why the visual helps sort of tie in some of our probability concepts and some of our results like this, 1/8 just from counting, but also 1/8 from multiplication. Okay, if a student selects answers at random, so again, any of those paths are possible. So I'm going to just kind of delete this path here so we can kind of have a slightly more clear view of everything. So if a student selects answers at random, what's the probability they select exactly 2 false answers? Not meaning incorrect, but literally just they have 2 false answers in here. So that would be, let's say we can go down the path. So if we started with true, then I guess the next 2 would have to be false. So they could have taken that path, right? True, false, false. If we start with false, we could go straight to our second false, but then we would have to do true. That's exactly 2 false answers. We could also say, okay, if I went to false, I could answer true, but then I would have to answer false, so I get my second one in there. So there's 3 different places we could end where we say, okay, we had exactly two false answers along the way. So that would be 3 paths out of the 8 possible where we get exactly 2 false answers, meaning we also have exactly 1 true answer.